What's up, everybody? This is a Sparrow with a Gun, back with our How to Train Your Turtle series. Yeah, I did move inside. I got really tired of getting bothered by the stupid zombies and skeletons and whatnot. So this is, I don't know if I showed this or not before, but this is my computer room in my dirt tower house that I'm still working on, still trying to build. I've been doing a lot of other stuff on here. So this is an advanced computer, and I've got my disk drive that kind of like what we talked about before. When we're referencing like disk drives and all that kind of stuff, that's kind of what it is. So I think I have an idea that I got from watching one of Good Boulderfist's FTV videos. What he did was in his video was he had talked about doing, and I don't know if he has or not because I'm way behind on my watching other people's Let's Play stuff. But he had talked about, at least in the video I just watched, doing a wall that was like you could replace the wall by using turtles that were behind it, and then they could remove the blocks and then place other blocks. And it gave me an idea of a basically retractable screen. So eventually, and I think I might do it in this series so that you guys can kind of see how turtles work and stuff as I'm working on a project, and it'll kind of make things more focused. But eventually what I like to do is have this computer here set up to where I can run a command, and through the wireless things it can talk to turtles that are behind this wall, and they will all simultaneously remove the monitors and then replace it with the same wood planks here so it looks like a wall. And then you could tell them to run it again, or, you know, whatever the command names are, and then it would replace it with a monitor. So it'd be like a retractable flat screen, and I think that would be awesome. I think, I didn't check this, but I think, yeah, okay, there is, ooh, except for, hold on. Do I have another block? I do. I'm gonna need a stand here. Whoop. Okay. Okay. Okay, that's... Okay. So that's the end of that. Tell me this isn't... Ah, crap, it is. How far does this go out? Okay, that's the edge. Well... So I need this. Okay, well, what I'll probably end up doing is filling this in. Let's see. Yeah, we'll probably just fill this in. And then put dirt or grass going up this way and cover this up. But that's something I'll do in a different video. It's not really related to this, but you can see what I'm talking about. If I can get all turtles behind this, then they can basically remove and replace. So what we're going to work on is, I got an idea that for this episode, I'm going to write a script little by little, step by step, so you can see what we're doing, that will basically remove this monitor without me having to do anything. Again, it'd be faster for me just to pick it all, but it's a simple but quick example of how you can code turtles. So here's Shredder. We got Shredder. Now again, at some point when we get past the basics, we'll do we'll start coding in RedNet so that you can just run a program on a computer and then the turtle will do it. Right now I'm not dealing with it right now because it adds another layer of complexity to the programming. So let's say, so first off, when you're in the turtles, you can, to make a new turtle program, you type edit, space, and then the name of the program. So in this case, we'll do remove monitors, or mon. And now this is your editing window. Now, for any of you that are watching this that are programmers and just don't know about turtles, you can actually, there is a means to find these files. Like if you just type something in here and then save it and then you exit it, there is now a file in the game world under computers, under ID. So you would basically go to your FTB folder, go to Minecraft, go to the world save, and then go to computers, and there should be a folder number so that's just labeled 27. When you go in there, it'll list all the programs on the computer. So well, all the ones that you've made. So not the defaults, but if you go to programs, you can see remove monitors right here. So this will show up in the folder as just it's just a file. Windows doesn't know what to do with it, but if you have like Notepad++ or something like that, you can right click on it and tell it to edit, and you can go in and use that. I've used that quite often. I'm not going to in this because I want you guys to actually see how we're coding this, but for really extensive programs that you know, you're not worried about anyone seeing how you do it or anything and you're just wanting to get it done, I highly recommend editing the file externally, because not that the editor in this is bad, it's just very slow because it's using like a, you know, a DOS prompt where you've got to use the arrow keys to move around, and you know, there's not as much syntax editing that some of the actual code editors have. Now, moving on. So first thing we want to do is we want to dig out the front, and then we want it to move forward. And so what we're going to do is the other thing that you can do is you can actually make functions within programs. Now that's a little bit more of an advanced way of doing things, so we're not going to get into that right now, but it will actually, as you get more and more advanced into your programming stuff, it actually, it sounds funny that it's more code to write, but it actually simplifies things because you don't have to write things as often, because you could go through here, you know, and type dig forward, dig forward, dig forward, whatever, or do it in loops or whatever, but it's much easier to write a function that says dig and then forward, and then, you know, put that into a loop or something like that. So what we're going to do is, right off the bat, we'll type in, and oh, one thing I did want to note is when you're in a custom program and not a default, you don't have to use the Turtle API. I mean, you use the functions, but you don't have to type turtle at the front. So, wait a minute. Nope. Disregard that. Don't know what I was thinking. You definitely do. Sorry. I don't know why I said that, actually. That was dumb. I don't know what I'm thinking. So now, it's set up to do turtle dig. Oh, wait. Let's do this. Okay, so we have a line for turtle dig. Now let's do... Okay, let's do an if command. So we'll do if turtle detect equals false, then end. So what this is going to do is it's going to run, it's going to dig, and then it's going to check, it's going to run the detect command. And then if the detect command equals false, then it's going to do whatever is within this if clause. So we're going to tell it to do turtle forward. Now this should mean it's going to dig, it's going to check if there's anything else in front of it, and then if there's not, it's going to move forward. In this particular scenario, you don't really need the detect because you know there's not going to be anything in front of it because you just dug it. But for things, again, coming back to like the gravel argument, it's good to get used to doing detect commands. Now for doing something like gravel, what you would want to do is do a dig command and then tell it to sleep for 1 second, or you don't always have to do a second, but it's worth it, because again, you have to allow time for the gravel to drop if you were digging something with gravel, or any kind of sand or whatever that falls. because that way it digs and then it pauses, which allows the gravel or sand to drop, and then it runs the detect so it'll actually pick it up. Because you can do it like this, so it's in an if-then clause. So let's say else, which what this is going to do now is if the turtle detects something in front of it, it's going to come back true. So then the if sequence is not going to proceed because it does not equal false. So it's going to say that the condition is false and then it's going to move on. So you put an else sequence, which basically means if it's false, do this. Otherwise, if it's true, now we're going to do whatever's in this line here. So then we're going to add another dig command. Again, this isn't really needed for this particular situation. It's just an example of how you would do things. So we're going to run this. There. So he waited a minute and then he moved forward because it detected false. There wasn't anything in front of him, so he was allowed to move. Now, one thing that I did just do is when you dig a turtle, you do get everything back in their inventory, so be mindful of that if you're picking up a turtle that has a full inventory, because it will dump everything. So now what we want to do is we got that in there, so now what we're going to do is he's going to be in this block because he's going to move forward, so we want him to turn right. And then he's going to dig all this stuff and move forward. So the simplest way to do that is going to be a loop. And we're going to need him to move 1, 2, 3, 4, 5, 6. 6 blocks. So what we're going to do is we're going to bring up our program. Okay. And you can, what's the command for it? You can add comments by doing 2 dashes. So if you want to label this like start point, so that you know this is the first thing. And then you're going to say like first row. So this is a good way to keep your code clean so you know what you're doing. So what we're going to do is turtle turn right. And this is going to turn him facing the other stuff. Now here's where things get a little more complicated. This is what we're going to do here is a loop. Now loops are different for each programming language, and that's kind of even for people who have programming experience. If you've never done Lua and you get in it took me a while to get used to it too, and I'm not too familiar with the for loop. I haven't used it a ton, but we're going to try this because I think this is how you do it. It's going to be for, and then you can use a variable here, such as number of rows, like num rows, whatever. Most of the time, when you get into looping programs, a lot of programmers just use I or J or a sequence of both as you stagger into loops. Because it's simple and all you need it for is an iteration, so it's I. But we're going to say I equals, let's see, 1, 2, 3, that's 6, and that's to the end. So we'll start with 1. Oop, not 41. Heavens no. Okay, I equals 1. You do a comma here. I forgot to mention that before. In any program or function that the turtles use that need multiple arguments, you do commas to separate arguments most of the time. Some exceptions, but most of the time everything's separated by commas within the parentheses. So I equals 1, and then we're gonna say 6 is the end point. So I is the start, 6 is the end. And then you can add a iterator. So like if you wanted to increment I by 2, so it would go 1 to 3 to 5, etc., then you'd put like 2 here. I believe it's here. Again, I'm not too familiar with that. If you leave it blank like this, I believe it just defaults to 1. So it will always, after each loop, it will add 1 to I. So it keeps a count of how many times the loop has run. I think this is how you do them for Lua. Again, I'm not positive. And I think Lua needs a do command. I'm not sure. I'm a little rusty with the for loop. I haven't used it all that much in Lua scripting, but it's probably the best way to do this one. So now what we're going to do is do turtle.dig, which is going to make him pick up the next monitor, and then we're going to move him forward. I'm not going to do a test detect command and all that stuff because we know it really doesn't need it. Now, in theory, this should make him, there's no block here, so it should make him dig anyway, move forward, turn right, and then dig all the way along here and stop, in theory. Now, granted, one of the rules that I have as a programmer is nothing hardly ever works the way it's supposed to the first time, but much like this. Remove mon. Okay, now one of the things... Wait, what? That is the program name, right? Really? I can't even type program. Just making all kinds of errors. Remove mon. So why isn't that working? Okay, what's name expected? I believe it's saying there's a problem on line 14, so we're gonna see. 1, 2, and there's a, over here there's actually a line number so you know what you're on. 14. Okay, I'm gonna pause this for a second and then check out and see what's going on. Again, I messed up the loop. I figured I did, but we're gonna see what I did wrong here. Okay, so found the problem. The problem was that my other experience with languages, instinctively I put parentheses in the for loop. Apparently Lua does not need that. So now let's try this. There we go. So he moves, he digs, a little bit of lag, and he stops. Good. Alright. So that worked. Wait, where'd he go? Oh, crap. Hold on. Shredder! Come back, Shredder! Okay. So, yeah. I'm actually surprised that worked the way I wanted it. Usually I have to debug things quite a few times. Okay. So now what we want to do, to make this even more complicated, is we want him to, when he gets here, so at the end of that loop, we want him to turn around, dig up, and then do the whole thing over again. Now this is where functions come in, because I can write this to where it does a loop, or I can write a function that it does one row, so then when you loop it, you just tell it to do that. So that's what I think we're going to do next. Okay. So what we're going to do is... And one thing that I have found is it's important to write functions up at the top of programs, usually. Because I don't know if Lua will do what's called a prototype, which is basically where you tell the program there's going to be a function used here, but it's not defined, and then you define it later in the file. But because I don't know if Lua script and Computercraft will do prototyping, I just write the functions up at the top so that when you call them down in the main program here, like this is all main program stuff. When you tell it a function, the computer sees it as, I'm not going to use that until you call that name. So it just skips all of that code and moves down to the program. But if you call a function down in the main program that hasn't been defined up top, it doesn't know what to do with it. So it's important to define your functions up here. And the functions are done by the function keyword, which is, go figure, it's function. Now what we're going to type here is row, and then close the braces so that it shows it doesn't need any arguments, and then we're going to end it. So this basically tells the computer there's a function called row that doesn't require any arguments or variables, and now it's going to move on and do this, which what we're going to do is we're going to copy this row. So it's I equals 1, 6, dig forward. Okay, so that's simple. So now what we do is make the for loop. Do. And, why did it tab? I didn't tell it to do that. End. Turtle.dig and turtle.forward. Now, so that's a function, so now what we can do is come down here, and we can actually change this and remove all this to where he turns right, and then we just call row. And it should, in theory, do the same thing. Now, what we want him to do, though, is at the end of this row, we want him to move up, turn left again so that he's back the other way, and then continue and do another row of 6. And we're going to do this 1, 2, or how many is this? 1, 2, 3, 4. So we're going to do this 4 times, is the idea. So the other way we can do this is write a loop for this to where I equals 1, and we do it 4 times, and do. End. Now, the only issue with this, let's see, let's walk through this. He'll go this way from row, at the end of the row, he'll move up, turn left, go forward. Now when he gets here, go up, turn left, forward. Okay, so that should still work. You have to pay attention with that when you're doing multiple back and forth paths, is that they're going to line up the same on both counts. So that when he gets to this side and has to turn around and go up here, that you don't end up making him go off in some weird direction or something because your code has it working for one side but not working for the other. And in this case, since he's going to turn all the way back around and go this way, if you do 2 lefts again, he's just going to turn around and go back that way. So it should still work. So what we're going to do is we've got the row command. So now let's tab that out. So now what we're going to do is tell it to turtle dig up, up, turtle turn left. And you could do right too, it doesn't really matter because you're making him do a 180 anyway, so 2 rights, 2 rights do make the same as 2 lefts, apparently. So dig up, turn left. Oh, I forgot the move up. That's important. The dig commands do not move the turtles. So that's an important thing to remember. So he's going to move forward, do all that, turn right, do a row, dig up, move up, turn left, and then it's going to end, and the loop is going to call it again. And this should be 1, 2, 3, and 4. Now, the one problem here is when he gets to 4, it's still set up to do an up command, so he's going to move up and get rid of this wooden block, and he's going to turn left and do all that stuff at the end of the loop. So, the one thing you can do, if you know that ahead of time, is do this, which I'm going to do here, is if I is greater than 3, meaning it's on its last iteration, it's going to be equal to 4, which you could do that too. You could do I is equal to 4. Now, that's another thing I need to point out for those of you that aren't familiar with programming. You notice I equals 1, but down here in the if condition I have I equals 4. This is because the equals symbol is actually an assignment condition. So I'm telling it that I is equivalent to 1. So if I was equal to 5 before this, it's going to reset it to 1 because that's what I've told it to do. The 2 equal signs is strictly comparative. It does not change the value of I, it just checks to see if it's equal to 4. That's very important because you can end up really jacking up your scripts by telling it something like this. This is going to end up really bad because it's going to change your whole script command to where it's not comparing anymore, it's actually changing I so that it equals 4. And that's going to mess you up. So if I is equal to 4, then... Oh, hold on a minute. My dog is doing something crazy. Just a minute. I'm going to pause the video again. Okay, sorry about that. One thing I did notice while dealing with my dog and thinking about when I came back to look at this is that I actually have this in the wrong spot. It's the right idea, but the wrong place. Because... Oop! That's too much. Put that back. So... Because if I put it down there, it's not going to do anything because this stuff is already going to have run and it's already going to have dug up that wooden plank up there. So we're going to put it up here, so after it runs the regular row, it's going to check to see if this is the last loop iteration or not. If it is, then what we're going to do is... I forget how this works. I'm going to try this. I don't remember if this will work or not. It would work in other languages, but I'm not sure. I'm going to try and do a break command. Because what I'm trying to do is basically break it out of this loop. Actually, no, I've got a better idea. Better idea. Much better idea. Okay, what we're going to do is this. If I is less than 4, then what we're going to do is all this stuff. That's a much better way to do it. I'm glad I thought of that. So basically this will keep it to where, and we always need an end sequence for any kind of for loops or if sequences, they all need end termination lines. What this is going to do is basically, for the first 3 rows, while it's not equal to 4, or less than 4, it's going to do the dig up and turn left thing. When it hits 4, this if sequence will come back false, so none of this will happen, thereby it will prevent it from digging up the wooden plank at the top. We're going to change this to rows. Alright, so in theory, again, it doesn't always work the first time, so we're going to try this. Remove monitor. It is case sensitive too. Okay, line 25. I forgot a then, I guess. Line 25. Yep, I did. Okay. Okay, now we're going to see him go. So he'll do that. Digs up, turns around, digs. I don't know why it's blinking so much. It's a little bit of lag. And he digs up, turns left, goes, digs up, turns left. Now here's the moment of truth. Will he keep going? Nope, he does not. Sweet. So that's how you do that. And then if you wanted to, you could add a line at the end, which I actually meant to do. We're going to grab this and break him. And what we're actually going to do here is we're going to add a line at the end to basically return is all. So what we're going to do is he's going to be up here facing this way, so we're going to have him turn right, so he's facing this way. Move down 1, 2, 3 blocks, and then move back 1. So, turtle, turn right, and then down. I think that's the command. We'll find out in a minute. And again, you could do a loop for this, but this is basic stuff that I just... It's specific, like I want him to do a specific amount of things and stuff, but just for, you know, just for the principle of it, we'll do it this way. Because this is, it's probably a better way of doing it. This is something simple, so it's not really necessary, but it's good practice. So turtle down and then back. So yeah, and I forgot to mention the file manipulation for this stuff is you hit the control key and then you can save, exit, or print, and you navigate this with the arrow keys. Print, honestly, I guess this is supposed to print if you have an actual printer, like a computer craft printer set up, and then you could make, like, you know, a stack of printed paper and a bunch of other stuff, but I don't really know if there's a point to it or if there's a way to then take the printed paper and load it to a disk, or I don't really know. I haven't messed around with that enough, so we're gonna run this again. And see, since I don't have any real detect commands in there, he's just gonna run the loop again. You know, if you had the whole, you know, if nothing's in front of you, then don't move forward or something. And now turn right, down, and back. See? It's just that simple. So yeah, I hope this wasn't overly complicated. I know I'm very comfortable with this kind of stuff. You know, so if I'm going too fast or something, or you want me to elaborate on another point or another program or function, please leave a message or a comment or something and let me know. I have no problem being specific about what I'm looking, or what I'm talking about, or whatever. I like I said before, just kind of started doing this because bass player is having some technical difficulties and we needed videos in the meantime, and he had been suggesting I do this for a while because him and Adrian both aren't real familiar with turtles and stuff, so he had kind of joked about it to me about, you should make a how to train your turtle series, you know. So kind of trying it out, kind of seeing if you guys like it. I don't mind doing it. It's a lot of fun. I like explaining this stuff anyway, so if I'm going too fast, brushing over stuff, I might have a tendency to do that, because some of it, like the whole equal to assigning thing, it's something I don't really think about anymore. I've done enough of it that it's just how it works. So yeah, please let me know if I'm going too fast, or if something didn't make sense, anything like that. Just leave a comment or a message or something. Let me know. If there's some specific function that you found on the wiki or something, or somebody told you about that you'd like me to go into detail on, if I can and I know about it or I do research on it, I have no problem doing that. Just yeah, let me know what you guys think. Hope you guys enjoyed. Hope it helped. And I guess I'll see you guys next time. Peace.